Hello. Yes, we welcome you back to PSSB, Physical Sciences, Silver Bullet, and it's me, Richard, here. Okay, let us look at the question. It says that two metal spheres carrying charges of that and that are placed as shown below. So we're having these two metal spheres. One is this one and the other is that one. And one carries a charge of negative 14 microcoulomb, and the other one carries a charge of positive 20 microcoulomb. The distances are shown. Then the question says, calculate the net electric field at X. Okay. How do you go about this? You have to know that we have point X as our interest, and this charge has influence at X, and this charge or the sphere has influence at X. So when the two influences interact, what you get is going to be net electric field of the two interference at X. So what are you going to say here? You are going to say electric field at X due to Q1. Okay. Let's see what we have this side. Okay, you know the Q1, which is negative 14 microcoulomb. Okay, you know the distance, which is 15 centimeter. What else do you know? You know K, which is 9 times 10 power 9. So with this information, what do? You quote the right formula. And the formula says E is equal to KQ over R squared. And K is 9 times 10 power 9. And Q is 14 times 10 power minus 6. Yes, these ones were supposed to be put in SI units, which is 14 times 10 power minus 6. And also this one was supposed to be changed to meters. So it's 15 divided by 100. And the answer is going to be 0.15 meters. So there we are. So we know the distance is 0.15 squared. So under this circumstance, we know E. Okay. Let's get that one. So there we are. This is our E. We can call it E1. And after getting it, what is the next step? Next step is to determine its direction, because you have to know that electric field or electric field intensity is a vector quantity. It has magnitude and direction. So how do you get the direction? You come at your point and you put a positive charge. And where the positive charge goes is the direction. So on assumption that right is positive and left is negative, so where will this charge go due to Q1? Remember, this is negative and this one is positive. what happens between the two is attraction. And during attraction is the charge, the testing charge, which moves. Where does it go? It moves to left. So this electric field is negative. And then after that, then you go to electric field at X due to Q2. Okay. So what do we have here? You have Q2, which is plus 20 microcoulomb, which comes to plus 20 times 10 power minus 6 coulomb. What else do we know? We know R. Our R is this distance from here to there. If this is 20 and this is 15, what is this one? It's 5 centimeters, which is the same as 5 over 100. So answer is going to be 0.05 meters. Okay, we also know K, which is that. So from here, what is next? Next is going to be our equation, which says that E is equal to KQ over R squared. And this is supposed to be E2. What is K? We know it. What is Q2? It is that one, 20 times 10 power minus 6. Divided by R. What is R? 0.05 squared. So what you get is going to be our electric field at X due to Q2. So there we are, 72 million. Okay, then we have to determine, is it positive or negative? You have to know that it is the point. This one is positive. So because of this one, where will this point go? Okay. You have to know that this one is fixed. It's the point X which moves. And where does it go because of repulsion? It goes to the left. And left is what? It's negative. So from there, you go proceed and get your innet. Our innet is equal to E1 plus E2, which comes to, okay, it is 5,600,000, okay, plus negative 72 millions. And what you get out of that is going to be our innet. So there we are. The innet is this. So what does that mean? What does the negative imply? Negative implies to the left. So there we are. Innet is 77,600,000. And that is that. So then comes this question. It says, calculate the force experienced by an electron placed at X. Okay. So what do we know about point X? We know E at X. We found it as 776. Yes, that is it. 77,600,000 Newton per coulomb. What else do we know? We know the charge on an electron. So the electronic charge is 1.6 times 10 power minus 19 coulomb. Okay. And we are looking forward for the force. So when you look at this data, it gives you this formula, which is E is equal to F over Q. So E is known, it is 776, which is equal to F over the charge, which is 1.6 times 10 power minus 19 coulomb. From here, what do we do? You calculate F. So our F is going to be equal to that. Okay, which is 77,600,000 times this. And what you get out of that is going to be the force in newtons. So there we are. The force is that. That's the force which is experienced by an electron if that electron is placed at X. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet. Don't forget to subscribe. Don't forget to like, to comment, to share. Yes. Yeah, we are simply the best. Bye-bye.